So our first question is, simplify cosec theta times sec theta minus cot theta. Now, usually to simplify any trigonometric expression, the best strategy is to rewrite all the trigonometric functions in terms of sine and cosine. So that's what I'm going to do in this question here. Let me rewrite my question again. Now, we are going to replace cosec theta, sec theta, and cot theta in terms of sine and cosine using the reciprocal and quotient identities. So, you can see that cosec theta can be written as 1 over sine theta, secant theta can be written as 1 over cos theta, and cot theta we know is cos theta over sine theta. Now, I have two different fractions here. Let's make the denominators same. Now, to make the denominators same of both the fractions, I must multiply my second fraction by cos theta. That means multiply both the numerator and denominator by cos theta. Doing so will give me this. You can see now that from the first fraction, if I club these two expressions, I get 1 over sine theta cos theta minus cos theta times cos theta will give me cos squared theta, and in the denominator I have sine theta cos theta that comes here. Next, if you look at the two fractions that we have now, the denominators are same. And hence, we can just combine the numerators together because they are like fractions. So, we have 1 minus cos square theta in the numerator divided by sine theta cos theta. Now, if you are able to recall the Pythagorean identity, we know 1 minus cos square theta, this part of the fraction, can be written as sine square theta. The denominator, sine theta cos theta, remains the same. Now finally, we can see that we have sine theta both in the numerator and in the denominator. Let's simplify this. So I can cancel one sine theta from the top and one sine theta from the denominator. We are left with sine theta over cos theta, which using the quotient identity is nothing but tan theta. You can see that I have been able to simplify a complex trigonometric expression, this just in terms of one trigonometric function, tan theta. Next question. Simplify sine square x times cos x minus sine of pi over 2 minus x. So let me write the question again. Now we know that this term here, sine pi over 2 minus x, can be written as cos x because of the co-function identity. So we have replaced this term of our expression as cos x. Next, you can see that we have cos x common in both the terms in this expression. So let's take cos x outside as common, and in the brackets I am left with sine square x minus 1. You can do the distributive property to cross-check your answer. Next, sine square x minus 1, this part of the expression here, can be written as minus cos square x using the Pythagorean identity. Now, if you're wondering why did this minus sign come, let's see here. We know the Pythagorean identity for sine and cos is sine square x plus cos square x equal 1. Now, if you take cos square x on this side of the equation and 1 on this side of the equal sign, what will I get? Sine square x minus 1 is equal to negative cos square x. So you can see that I have sine square x minus 1 here, which is equal to negative cos square x, and thus I have replaced sine square x minus 1 by negative cos square x. Now if I multiply cos x with negative cos square x, these two terms here, I get negative cos cube x, which is the answer to my question. Let's have a look at our next question, which is rewrite 1 over 1 plus cos x as an expression that does not involve a fraction. That means we should have our answer only with the numerator and no denominator. So let me write the question again. Now, one of the techniques to solve this type of a question is if we multiply the numerator and denominator by the conjugate. So what do we mean by this word conjugate? Now, if we flip the mathematical operator, that means we change the plus sign to minus sign, or if we change the minus sign to the plus sign and these two terms in a binomial remain the same, then what we obtain is the conjugate. So the conjugate for 1 plus cos x is 1 minus cos x. And you can see that I have multiplied both the numerator and denominator by the conjugate. So if I multiply these two fractions further, I obtain 1 minus cos x divided by 1 minus cos square x. Now, if you're wondering, how did I obtain this? Then one way of solving or multiplying these two binomials here is to make use of this identity, which you had studied in the previous grade. That is, a plus b times a minus b is equal to a square minus b square. If you're not able to recall this, then you may use the FOIL method to multiply these two binomials, or just by using the distributive property, you can multiply these two terms. Any strategy that you feel more comfortable with. Now, 1 minus cos square x, this denominator here, can be replaced by sine square x using the Pythagorean identity. Now, the next step is an interesting one because I am going to write this fraction as the difference of two fractions. That means I'm going to break this big fraction that I have. So what we are going to do is, look here, this is going to be the first part, the first fraction. Then we have the minus sign, and next part of or next fraction would be this cos x over sine square x. So you can see that I have written this fraction here in terms of 1 over sine square x minus cos x over sine square x. Well, let me tell you that even if you club these two fractions, you will get this result again. So it definitely shows that the result or the value of the fraction doesn't get changed at all. Now, 1 over sine square x can be written as cosecant square x, which I have here, and cos x over sine square x I have written in this manner. That means I've just written sine square x as the product of sine x and sine x. Now, why did I do this? Because using the reciprocal and the quotient identities, I can write this term cos x over sine x as cot x and 1 over sine x as cosecant x. This is my answer. You can see that my answer does not contain a denominator, and thus it is not in the form of a fraction. It is time that you try and solve a few questions on your own. You may pause the video here and resume when you are ready with the answers. The answers to the questions are: